Okay, so last time we started talking about interfaces. So we have this idea, and I'm actually going to create a slide here. I know I said it out loud last time, but I'm going to create a slide that takes what's in this slide right here and kind of puts it in Lippmann speak. So interfaces versus classes is really what I want to cover here. So we already know that a class is an object that contains, I'm going to put this in all caps, implementation for the fields, constructors, and methods that make up the object. All right, with the emphasis being here is that a class is an actual implementation. It actually has written the logic to make something happen. And then when you create instances of that class, you are creating instances of things that already have abilities. Okay, you can also, through inheritance, extend classes to give yourself a base for something new and then add some stuff to it. But a class requires an actual implementation, as opposed to an interface is a collection of, I'll just say, things that a participating, or in the Java speak is the implementing class must implement in order to claim they are compatible with that interface. So interfaces do not dictate an actual implementation. They do dictate that there must be an implementation. All right. So that's the difference between these two things. They look a lot. We're going to look at the runnable interface, since we're going to be talking about threads today. We're going to be looking at the runnable interface in the Java documentation. And we're going to see, even though runnable is actually a very small interface, that it looks similar to classes when we went and looked at the methods for like strings and things like that. So if I come out here and I go to the runnable interface, so I'm in the Java documentation thing. So the interface called runnable is inside of java.lang. That's where it lives. All right. And all it says is that you have to have a method called run. That's it. Now, the interface itself does not actually implement the run method. All it says is that if you want to claim that you are a runnable class, which means that you're claiming that you're going to implement the runnable interface, if you're going to make that claim, you have to have a method called run. Because whoever is going to be using that class with the knowledge, they've advertised that this guy is runnable, then they can now know that they can trust, they can call a method called run and it will do something. All right. Because in order to participate in the runnable interface, you have agreed to write a method called run. All right. Now, we're going to look at the Java thread class. And we're going to see the thread class is a class. So as opposed to an interface, it's a class. And this class implements the runnable interface. Okay, so we're seeing those two things together. So there exists a runnable interface. And then as one example, there exists a class called thread in Java that implements the runnable interface. That means that we know that that thread class will have a method in there called run. Scroll down here. Here's the run method. Okay, now the default run method of the thread class does nothing. So the implication is if we want to make a class that is a thread, if we want to inherit from the thread class to make our own special kind of thread, we can override the run method and put our own stuff in there. All right, and it's important that we do use the thread class to do this, because we can look at the thread class and say, this guy is kind of magical. All right, the thread class is really this special kind of animal. And I think I talked a little bit about it last time with blocking code, things like that. Yeah, we talked about code that blocks. So when you have an application that's running and you need more than one thing to happen seemingly at once, all right, you could even think about this like in a web browser. Okay, if you have a program that's a web browser and you're on one tab and you start downloading some large file on that tab, okay, that file you would like to keep downloading even if you go and open up another tab and keep browsing, keep going to other places and stuff like that. That's something we take for granted today, but that's not something that always existed in our computing operating systems. So at the core of our operating systems, so if you've had the 350 class, you'll talk about this kind of stuff. When you take the 450 class, we actually implement this kind of stuff. We have the ability of creating multiple processes, or the more modern ways to creating multiple threads within a single process, where more than one thing can at least seemingly happen at once. We're at the mercy of how the operating system schedules it, right? If we have that web browser and two things are happening at the same time, two threads are running in that web browser at the same time, you're still at the mercy of when the CPU gives those things CPU time, okay? And who's in charge of that? It's the operating system. That's not us as programmers. As programmers, we're just saying, hey, here's a thread, go. And we're reliant on the operating system to do the rest of the magic, all right? But Java specifically, being a running inside of a virtual machine, has this almost a strange relationship with the operating system, because it's like one level of abstraction further removed. Our Java program running inside the Java virtual machine, which is running on the operating system, we have one more level of abstraction that we're removed from the operating system. So what we actually do here is the thread class is the special class that knows how to work with the Java virtual machine to work with the underlying operating system to actually create a real true to life thread that the operating system respects and will schedule for the CPU, that kind of stuff. All right. That's why, if as programmers, whether we're Java programmers, C# programmers, whatever, threads exist in all of our modern languages. We would use the thread as our base and then modify it as we want it to be modified, so that we can just tell a thread to start. And that start function for a thread would do whatever magic is required under the hood to get an actual thread running on the operating system. All right. So that's not something that us as programmers need to handle. Somebody wrote this and had to make that work at some point, but now we can just leverage that tool. All right. So we'll just say the thread class implements the runnable interface, which means the thread class has a default run method that does nothing, but it still exists. So this technically is compatible with Runnable. If we want to create logic that can happen in a non-blocking manner, we can extend the thread class and write our own run method. Why would we do this rather than just have our own class that implements Runnable? And the reality is that threads are, let's put it, these are magical objects in Java that know how to get a thread started on the OS. We couldn't do that on our own, or at the very least, it would be very, very difficult for us to jump through all the same hoops that guy's already jumped through. So what we do is we extend thread, write our own run method, and then call the start function on the thread, which does the magic and runs our code from the run method on the OS. All right, so we are writing a method called run, overriding the default one that does nothing that comes with threads. But then we're actually calling the start method for threads. And that start method, that's the magical guy. We definitely don't want to overwrite that one. Okay, he's the one that does the special sauce that goes and talks to the OS and creates an actual thread and then says, okay, go do whatever the run method says that our developer said they want you to do. Make sense? All right, so that's this relationship between the thread class and our interface. Nothing keeps us from creating our own normal like player class or something like that and implementing Runnable and writing a function called run. That makes us compatible with the Runnable interface. Okay, the Runnable interface does not imply a multi-threaded application or anything. It just says, hey, if you're claiming to be Runnable, I'm going to find a method called run. That's it. That's it. Last time I probably used an example with like the UPC guns at like stores, where every single UPC gun, even if it's from different manufacturers, knows how to read has the 2 features, 3 features, whatever it is, of reading UPC codes on cereal boxes or whatever it is. Okay, so maybe they're I don't know, what would the name of that be? They implement the scannable interface, which says you have to have these 3 functions, one that can read the bars, another one that does something else, doesn't matter, but they all do have to do those core set of things in order to claim to be things that are scannable. Okay, the thread class happens to give us a baseline for a implementation of Runnable that also does some extra magic behind the scenes. All right, so let's see, how do we want to, we're going to go into Android Studio here. I'm actually going to create a new project. New project, and we'll do this as an empty activity. And we're going to call this guy CSC250 thread example. Do this in Java. All right, so what we're going to do is first we're going to show an example of something blocking that causes a problem. All right, so what we'll go ahead and do is we will, in our user interface, we will not have, there we go. Divert view, linear layout, make that guy vertical. And let's go ahead and give ourselves an edit text box to like read something in. We'll read in some plain text, enter the name or something. Then let's go ahead and let's give ourselves a, let's see what's going to be the best way to do this. I'm going to give myself a second edit text. We'll make this one a number. So we'll put in the hint for this one to enter some name. And for this one, we'll say enter a number. And then we'll go ahead and put a button in here. And we'll make the text on the button say, press me. And then let's give ourselves a little text view where like our answer will go. And we're going to call this guy, we'll put nothing in there at first. And we're going to call this guy our number output TV. So we're going to enter in a number here, and then we're going to click this press me button. And what we want to have happen is we want to have, I'll have to look up how to put something to sleep for like a second. We want to have our thing count from like 1 to whatever this number is, and put the next number in here every like 1 second. All right. Let's just do Java sleep. Thread.sleep. Good. Actually, it's going to play into exactly what we wanted to do here. All right, so let's just start with that. In fact, we can do our initial thing here. We'll just do it with the press me button before we hook up anything else, and we'll just have it maybe show the numbers between 1 and 10 in that text box, 1 second at a time. All right. Hopefully Android's okay with us putting the thread to sleep. Otherwise, we might have to deviate from this a little bit. Let's see, let me go back in here, and that is called number output TV. So I'm going to give myself, it's inside the class. Private text view, number output TV. This dot number output TV is equal to this dot find view by ID, r dot ID dot number output TV. Then we're going to go ahead and write our handler for our button. So this is our public void on press me button pressed. I'll take a view as a parameter. All right, and this guy's job will be to go through a loop. So for int I is equal to 1, I is less than or equal to 10, I plus plus. We're going to do something 10 times. And what we want to do is we want to update our number output. So we'll say this dot number output TV dot set text to the empty string concatenated with I. Now, if we just run this right off the bat here, you're probably not going to see the numbers change. You'll end up just seeing a 10 there. So let's actually go ahead and try that. So let's go back out here, go to our button, set his on click. All right, so when I press the button now, when I run it, I'm guessing what we're going to end up seeing here is just the 10. Everything in an Android application is running in a single core thread for that particular activity. And when you start changing the things that are on the screen, they don't necessarily update instantaneously because all this other logic is happening behind the scenes, right? So your interface updates happen kind of, they get interjected in with whatever the logic that's running on the CPU is. So this guy will finish running, and eventually this will turn into a 10. We might even have to click on it or something like that to get it to be a 10, but we're going to look at doing this a different way here in a second anyways. So there's my press me, and we got a 10 on there. We didn't see all those extra little things in the middle. We didn't see the 1, the 2, the 3, or anything like that. Let's see if we could exaggerate it a little bit and maybe have it go to like 100,000. We might see a number in there in the middle, something like that at some point. Just if the interface got a word in edgewise. No, didn't see it. Okay, because that guy stayed there running constantly. Now, because I've advertised that the main thread, that the whole application runs on a single main thread, putting this to sleep for 1 second, and this probably throws an exception. So we'll just say try to do all this. Catch exception E, do nothing. Okay, well, it didn't crash, so that's good. It's not updating though, and that's okay. But we certainly don't want to do this. Why don't we do this 3 times? So we only have to wait 3 seconds for our final answer instead of 100,000 seconds to make sure that it's functioning the way we wanted it to function. Okay, there's our 3. So we went through once, put the thread to sleep, went through twice, put the thread to sleep, but the thread it put to sleep was the main thread. So our interface did not update, right? And we might actually still have problems making it update this other way, but so at this point, we're a little bit playing the game with Android's user interface stuff. But let's see if we can pull this off. I have a feeling we at least have a fighting chance, but we'll at least see how this is supposed to work. So what we really want to have happen here is instead of having this stuff happen on the main thread, the thread that comes with your running Android application, maybe we create our own thread whose entire existence is to sit there and go through some counters and update a text view, that kind of stuff. but have that happen on a different thread. I'm actually pretty sure that that different thread's not going to be able to update it, but let's go down this path anyways. So let's first create our thread. So we're creating a new class. All right. And we're going to call this guy, we'll just call it my thread. Okay, this is going to be your own special kind of thread. All right. And my thread will extend thread. So he's going to be a normal plain Jane thread, but with a little bit more. All right. So what we want him to have access to is a text view. What we call this number output TV, something like that. And then we'll have our constructor for my thread take in a text view as a parameter. And what this guy will do is he'll set his own text view equal to the text view you passed in. Then we're going to write our run method. This is what the thread does when it starts. And what we're going to have this thread do when it starts is try to do this stuff, but we're going to say, I think I'll be able to say this dot sleep. Let's see if with a call thread dot sleep, it does it with the most local thread, because I wanted to do it for this thread right here. But we'll see what happens. All right. So this is my own thread called my thread, which extends the base thread class. I decided that, you know what, in order for my thread to work, he's going to need access to a text view. All right, so we'll go ahead and do that. But then when we tell that thread to start, that thread's going to come into its run method here and do this 3 times, waiting 1 second per. Now thread.sleep here, let's see if it tells me thread.sleep. Doesn't tell me it there, but let's see if I can see it inside of the thread class Java. Look at that sleep. Causes the currently executing thread. So hopefully that means it'll notice that this is a secondary thread that needs to go to sleep. But we might have to do something interesting with this, I guess. So let's see where that rabbit hole goes. So this guy will update that text view to a certain number, then go to sleep for a second, all while maybe the main thread is still functional. Because I think we saw, I don't know, we didn't try to do it, but we wouldn't have been able to do other things in our user interface while that thing was running 100,000 times. That main thread was busy going through doing something 100,000 times instead of letting us keep doing something in our user interface. So you can imagine, let's say that you have a part of your application that's going and grabbing the current updated sports scores or something like that. And that takes, let's call it 2 seconds for it to hit some, cloud service somewhere, grab the score, bring it back down. We don't want our whole interface to lag for 2 seconds while it's going and doing that. That's the kind of thing we would do inside of a thread so that it gets, our application feels clicky and stuff while it's retrieving some delayed information or something like that in the background. All right, so this thread's job is to go through and do something 3 times, updating a text view with a number. And because we're going to do this off of the main thread in our own secondary thread, we hope that this will allow that text view to update. Although text views, the user interface stuff does happen at a different rate than it still runs on that main thread. So it's possible we won't be able to see it here. If we don't, then what we'll do is we'll look at it at logcap at the console, because we'll definitely be able to do it there. So here in main activity then, what I'll do is instead of putting our logic here, I'm going to go ahead and create a my thread. MT is equal to a new my thread, and we'll pass this guy our text view. And then we'll tell our thread to start. So we are creating a brand new thread of execution, a secondary little worker bee that's running alongside the main thread that our Android application is currently running on. And this isn't an Android thing. This could be normal Java, whatever. Just when your program is running, it's running on a main thread. If you want something else to happen pseudo simultaneously at the very least, you would create a secondary thread to go and do that stuff so that your main thread can keep doing its thing. All right, so we'll go ahead and create an instance of our myThread class and then tell that guy to start. When we call it to tell it to start, it'll do its magical operating system stuff and then ultimately call this function right here. This function says, here, I'm actually going to set this to 10 just since we shouldn't have a problem with it running in the background. Our application should still be able to do other things. So in this guy will just set it from 1 to 2 to 3 to 4, that kind of stuff. But we're not sure that the Android's main thread will actually let it get a word in edgewise to update this user interface. So we might need to do it in a different, show it to us a different way. But let's see. So we'll run this guy. It did allow it to do it. So you see how that guy's counting behind the scenes there? So it's doing this on a completely separate thread, meaning that our main thread is not being impacted. So what I can then do is while that guy was counting, here, I'm going to restart this. I could potentially type something up here and then maybe hit a different button and have it update a text view down here, secondary text view. All right, so now I have my user interface is still usable while this thing down there is just doing its counting crap, right? So let's go ahead and let's extend this for the moment to our 100,000. Just let it keep doing its thing in the background so that we don't have to race with our typing to get it to fill in quick enough. We'll go back to our user interface here. I'm just gonna update the, well, we'll just give ourselves another button. I'll put this button below that guy. That way we see our number in there. And here we'll even make that number a little bigger. There we go. Okay, and this button will be, maybe we'll set the text on this one to read name, something like that. And then we'll put another text view down below this. And we'll call this guy name output TV. And we'll bump his font size too. All right, so we're going to go ahead and give ourselves programmatic access to this dude and then also write a handler for this button. And what that button will do is it'll just read whatever is inside of our enter name, which is called, I'm going to change this. We're going to call this guy name ET. Now we're reading in from that guy. And so we'll read in from that, put that value here, all while this guy's still counting to 100,000. So our interface is still living, still responsive to us because the main thread is still waiting on us to interact with it. Yet we have this other thing in the background doing some stuff. All right, so we need name ET and we need name output TV. Private text view name output TV, private edit text, name ET. Then we'll go ahead and write our handler for this, public void on, whatever, set name button pressed. And this guy is just going to read in, so we'll say string name is equal to this dot name et dot get text dot toString, and then we'll say this dot name output TV dot set text to name. Okay, separate button, but all this button does is he's not creating new threads or anything. He's operating on that main thread. Just, hey, I'm going to read something. I'm going to write it out. I'm not doing anything that's requiring time in the background. Okay, so now we'll go hook this guy up. So the on click for this dude, we'll call the on set name button pressed. And it's going to read in whatever he wrote here and write it out here. All while we're going to click this press me first. This guy will be counting to 100,000 and going to sleep every 1 second. So something else is happening and not blocking us from using the rest of our user interface. So we'll go ahead and get the counter going. And I'll come up here and I'll type in Mike. I'll say, oh, so that crashed because, well, let's see what the error message was. I didn't expect that to crash. So we go to logcat. We're going to go to error. Yeah, it didn't like the didn't like this happening on the main thread while we had this other stuff running. I'm going to just run it one more time. So want to make sure that that whole thread.sleep thing may actually be our issue. And if that's the case, we can fix it since we're just having it count a bunch of times. So I'm going to try something. Oh, did we not hook up the wrong thing? This guy's called name ET. This guy's called name output TV. Oh. Oh, man. What didn't I do? What do you think? Yeah, I didn't do this crap. I gave myself variables for these in preparation for hooking them up, but I didn't actually connect them. So I didn't finish doing MVC here. So this dot name output TV is equal to this dot find view by ID r dot ID dot name output TV. And then this dot name ET is equal to this dot find view by ID r dot ID dot name ET. Now I've actually hooked those dudes up so they have programmatic access. We'll go ahead and get our counter going. We'll say Mike, read name, change this to Dave, read name. So now we have multiple things happening in our application at the same time using our multiple threads. Okay, so questions about how that's working. And a thread sounds difficult on paper, but when you actually look at our thread implementation here, this is pretty simple, right? We just said, look, I'm going to create a class. And I'm going to choose to extend this magical class called thread. And thread happens to implement runnable, which means that if I want this guy to do anything, I need to write my own run method that supersedes the one that came from the thread class, the one that came with my stuff, or came with the thread. But I'm going to say, you know what? My thread does differentiate itself from a generic thread in that my thread's performing a very specific task. It's performing the task that I trained my thread to do. Okay. And my thread, here's its constructor, it's going to need some stuff to do its job. Okay. It's going to need some stuff to do its job. And maybe it has the number output TV is what I'm passing it here, and it's connecting it with this, but really this guy's working with any text view. So nothing keeps me from creating two different my threads and calling and passing each one a different text view to update, right? So let's have a little bit of fun with this.
Question, Dr. Lim.
Sure, go ahead.
So when you say a class extends the base class, is that basically the same as class inheritance like we used in Python?
Yeah, it is class inheritance.
Okay.
This is Java's class inheritance. So we're saying my thread is a thread. He's everything that threads are, but then a little bit more because we've deviated from the default thread. All right. So now what I'm going to do is I'm going to actually give myself a random number generator. And we're going to still do some stuff in, well, I can move this inside of my try. Doesn't need to be in there, but I'll do it anyways. All right. So now what we're going to do is we're going to set our output TV equal to some random integer. So we'll say r.nextInt. And we'll put in here 1,000 for the bound. This will give me a number between 0 and 999. All right. But then rather than sleeping for 1,000 milliseconds, why don't we sleep for r.nextInt, and we're going to give it a bound of we'll give it a bound of 2,000. So it'll sleep anywhere between 0 milliseconds and 2 seconds. So 0 seconds and 2 seconds. If I wanted to sleep at least a little bit, I can add to it maybe plus 50, which would be 50 would be a 20th of a second, right? 100 would be a 10th of a second, 50 would be a 20th of a second. All right. So this will sleep between a 20th of a second and 2 and a 20th of a second. 2 and a 20th of a second. All right. But it'll be for this particular thread. Now I have 2 output text views now, right, on my screen. So I'm going to create 2 different threads from that first button, but hand them different text views. And each one of these guys, when I tell it to start, is going to start generating random numbers, outputting to their particular text view, whatever guy I set it to, and then sleep for some random amount of time. So we're going to have 2 different text views updating from 2 different threads, and they're going to get different numbers put in them and at different rates, probably, right? Unless we just, the moons align at some point, we get them both updating at the same time. So go back into main activity here. I won't change my onset name button. We're not going to use that there right now. So then inside of this first one, we'll say main thread MT2 is equal to a new my thread. And this will be this dot, this dot name output TV. I'll just pass it a different text view. So these two threads both operate on text views. They just happen to be different text views. And I'll tell each thread to start. So now we have our main system thread, and then we have two separate little worker bees who are doing, in this case, the same kinds of stuff, but outputting to a different text view. Go ahead and run this. Click on this dude. Now I think that thread sleep thing is a problem. Let me, I'm going to just take the sleep out of it real quick. Yeah, it's not getting a word in edgewise. Oh, wait a minute, wait a minute. I think it did work before. I just didn't put this thing inside of a loop, did I? Well, they'll say while true, do all this stuff. I only did it one time. Now it's just going to do it forever. Pretty cool. And obviously you can have as many threads as you want, but you will start getting diminishing returns. When you take the operating systems class, one thing you'll see in there is you'll see the difference between, there's a system call that we explore in the 450 class called fork, which creates a duplicate process, a whole brand new heavyweight process that the operating system has full control over. And that was the older way of doing multi-process programming. The more modern way is to do it through multi-threading, where an individual program on your computer, like in this case, our Android app, is getting an amount of CPU time with the processor. When you create a duplicate process using the fork system call, both of them are now getting their own collection of time with the CPU. Right, effectively doubling the amount of time this particular program gets with the CPU. So you can see how that could get abused, where you just keep creating copies of yourself and all of a sudden you could take over all the CPU time. So threading is a safer way of doing this, where an individual process that gets its own collection of CPU time, let's just make up a human number like 10 seconds. When it creates threads, those threads are now sharing that 10 seconds that the parent is getting with the CPU. So eventually, if a process spawns off enough threads, they end up cutting into their time on the CPU enough that they no longer get some of the benefits of having threads. So really, for us, the idea should be that a thread allows us to have code that doesn't really need to block, not block. All right, and the best example of this in real life would be like authentication, right? If we assume that there's, you know, you go to a website and you're putting in a username and password, or actually a better example would be Google. You go to Google and you're putting in your search. You don't want the person who comes to Google next to have to wait for you to finish typing in your search thing, and then for them hitting submit and for Google doing its whole search crap, right? Instead, you'd rather, when you come to google.com, it goes ahead and it spawns off a helper thread that will work with that particular person for their search and give them the output and things like that, leaving the original screen ready to help another person who comes up. And when another person comes in, it then spawns off a helper thread to work with them, so on and so forth. Make sense? All right, so for Friday, go back through our notes up to this point. We'll talk about the final exam on Friday, and I'll review anything you want me to review. Go back through all of our slides. The final exam will focus on the stuff since the midterm, but that doesn't mean stuff before the midterm isn't fair game. So go back through and look at stuff, look at the homework assignments, and ask any questions on Friday that you think are, that you want me to clarify before our exam. The exam will be on Blackboard next week. All right. Questions, comments, concerns, bribes. All right. I'll see everybody on Friday.